Let's look at angle between two lines. So let's say we have been given the direction ratios of a line. So ABC are the direction ratios. Okay, now we have been given only one. So this corresponds to a single point. So we require 2 points. So let's assume that the other point is the origin. From the origin, let's take the unit vectors along x, y, and z. So I is equal to 1, 0, 0, j equal to 0, 1, 0, k is equal to 0, 0, 1. Right? So now let's define the position vector of ABC. So vector using this ABC and IJK. So A times I plus B times J plus C times K. Right? Now remember, we can always change the values of this. Right? So the unit vectors will not change, but this will change. So let's, right? So we can change it to anything that we want. Okay. Now similarly, we have been provided the direction ratio of the other line. So let's say that is PQR. In case of PQR, again, let's define a vector using PQR and IJK. So P times I plus Q times J plus R times K. Okay, again, let's change the values of this just so that we have a different. So, and remember, when we have a dashed line, it means that the line is on the other side of the plane, XY plane. Okay, now remember, we can find the angle between two lines using either direction cosines or direction ratios. So first let's do the straightforward way using direction ratios itself, because that is what has been given to us. Now one thing that we require is the magnitude of these vectors, right? So let's evaluate the magnitude. So a square plus b square plus c square, that's the magnitude of the first line. Similarly, let's figure out the magnitude of the second line, that is p square plus q square plus r square. Okay, now it becomes easier. So let's figure out. Now remember, cos theta is equal to the product of the sum of the product of the direction ratios divided by the product of the magnitudes of the vectors. Okay, so a cos, that is cos inverse of a times p, product of the direction ratios, and now the sum of those products, b times q plus c times r divided by the product of the magnitudes. Now magnitudes are where is it? D and E. So D times E. Now here we are directly use the direction ratios to evaluate the angle between the lines. Now let's do it using direction cosines. But for that we have to first evaluate the direction cosines. So L1 is equal to A by magnitude of the vector, that is D. M1 is equal to B by D. N1 equal to C by D. So this is the direction cosines of the first vector, first line. Okay, similarly, let's look at the direction cosines of the second line. So L2 is equal to P by E. M2 is equal to Q by E. And N2 is equal to R by E. And the formula is what? Cos inverse of the sum of the product of the corresponding cosines. This would be L1, L2, sum of these. So M1 times M2 plus N1 times N2. So if you see here, 82.46, 82.46. So whether you use directly the direction ratios or you use direction cosines, you get the same answer. Now, two intersecting lines will always form two angles, right? So the other angle would be the supplementary angle to this. GeoGebra itself has a function angle between I think U comma V. Yes, 82.46, right? Okay. And if the angle is 90 degree, then the lines are perpendicular to each other. And if the angle is 0, that means they are parallel to each other. So that is angle between the lines.